Here is a practice math SAT problem. A solid square-based rectangular prism has a height of 50 centimeters and a combined surface area of s centimeters squared. If it is cut in half parallel to the square base, one of the halves combined surface area is 31 over 56 s centimeters squared. How long is an edge of the square base? So here we have a diagram of the solid square-based rectangular prism. Once we cut it in half parallel to the square base, in our diagram, it would be horizontally like that. We get half of it, okay? The rectangular prism is 50 centimeters height, and then half of it would be 25 centimeters over here. So we want to know how long an edge of the square base is, so we can label it as x. That's what we're trying to find. We can use some equations to set up the problem, namely, if we know that the combined surface area of the original solid square-based rectangular prism is s centimeters squared, well, what is that equal to? Okay, how many faces are there? There are 6 faces, 2 of which are squares, 4 of which are rectangles with dimensions 50 and x. So the square is x times x, and there's 2 of them, so we have 2x squared plus, and then we have 4 rectangles. Each rectangle has a dimension of 50 centimeters by x centimeters, okay? So it will be 50 times x to give you the area of a rectangle. This equals to 2x squared plus 200x. So that is equal to s. We can do the same thing for the smaller prism, okay? So the combined surface area is 31 over 56s, okay? And this is equal to, again, 2 squares and 4 rectangles, okay? So we have 2x squared again from the 2 squares, and then the 4 rectangles would be, okay, each having dimensions 25 by x centimeters. So we have 25 times x as the area for one of the smaller rectangles, and this is equal to 2x squared plus 100x. Okay, so this is what we have over here. Now, we can actually clean this up even further if we multiply both sides by 31 over 56. Multiply both sides by 56 over 31. So we get s by itself, and we have 2x squared plus 100x, and then we multiply it by 56 over 31, okay? And this would equal to 112x squared plus 5,600x all over 31. Now we see here that if s is equal to this expression over here, and s is equal to this expression over here, we are able to equate them together. So from these two, we can say s is equal to, or we can just say 2x squared plus 200x is equal to 112x squared plus 5,600x divided by 31. Okay? Multiplying both sides by 31, we get 62x squared plus 6,200x, and this is equal to 112x squared plus 5,600 or 5,600x. This is just a simple quadratic equation without any constants, so we just have x squares and x's. We can probably factor some things out and solve for x right away. Okay, so I'm going to move these two terms to the right-hand side, so subtract the 62x squared and subtract 6,200x. We get 0 is equal to 112x squared, and then once we subtract 62x squared, that would be 50x squared, and then 5,600x minus 6,200x, it will be minus 600x, and this is equal to, if we factor out 50x, okay, 50x is the greatest common factor between 50x squared and this 600x, we have 50x times x, finally, minus 12, okay, which means the solutions to this equation, okay, this is equal to 0, which means x is either equal to 0, okay, or x is equal to 12 over here. So we see right here that 0 is an extraneous solution. Extraneous solution, since we want to make sure that our edge of the square is positive, okay, so it can't be 0. So we have 12, okay, so we get that the edge of the square is 12 centimeters.